All right, class. I wanted to do some of these retake review problems so that then you could try them yourself. So let's just look through some of these expressions. We start with the quotient of a number and 4. Anytime it says a number, it's talking about some variable. And then quotient, that's division. So this is going to be x divided by 4. Again, I'm using the keywords in the sentence to help me determine what I'm doing. So this one's more complicated. It says the difference, that means subtraction, of 5 and, so I'm going to have 5 and then minus the product of a number and 3. So this product of a number and 3 are going to be together. Product means multiply. Actually, I'm going to use blue for multiply. Yeah, product means multiply. And it's a number, x, and 3. So 5 minus 3 times x, or 3x. I could do x times 3, but I'm in math. Whenever we have a number times a variable, we write it like that. Here is another one. We have 6 more. So 6 more being the addition sign. And so we have 6 more than the square of a number. And so the square of a number, that's x squared. And so this is going to be x squared plus 6. 4 less than a number tripled. So 4 less is minus. Tripled means times 3. That's a fancy word for multiplying by 3. And then a number, of course, is x. So we have, now 4 less, it seems like you would do 4 minus 3 times x, but think about what number is 4 less than, say, 7. Well, that's 3. So if it's 4 less, it's really saying minus 4. It's not saying 4 minus the number, right? And so that's when a word like less might be confusing. So even though the 4 comes before the less, the correct way to write this would be 3x minus 4. Because 4 less is telling you to subtract 4 from whatever comes after it. Let's try the same things in a table. Here's increase by 5 means plus, and of course multiply makes it easy for us. So let's just go through. Negative 4 plus 5 is positive 1. Oops. Let's make sure our color code's right, Mr. Buckley. Positive 1. And when we multiply 1 times 10, we get 10. Starting with 7, if I increase it by 5, that's 12. 7 plus 5 is 12. I'll show all of my steps for this one. 7 plus 5 equals 12. Negative 4 plus 5 equaled 1. And so then when we did this last one, we did 1 times 10 equals 10. And this time it's going to be 12 times 10. And that's 120. And now you need to be able to do this for any number n, right? And so you just need to list your steps. So first it's going to be n plus 5. And then you would keep the n plus 5, and now we're going to multiply by 10. Except you need to make sure the n plus 5 is kept together. That way, that happens first. And so if you were to properly simplify this, you would distribute to get 10n plus 50. Now, I won't require you to do that on the test, but that is what you would do it in the correct order. And so we do the same thing when using order of operations. Notice that here we would do 3 times 5 first to get 15. And then 17. But here, this is telling us, these parentheses are telling us to add first. 3 times 7 now, which is 21. Notice how the order in which we do things changes what we do. Number 7, Mal is buying ice cream bars for her friends. Let V represent the number of vanilla ice cream bars and C represent the number of chocolate ice cream bars. Which models the total ice cream bars? So it wouldn't make sense to multiply them because they're just different kind of bars. So if she bought vanilla and she also bought chocolate, we're going to add them. Wouldn't make sense to subtract them since she's buying both of them. I don't know what division would even do. The bass fishing team is purchasing more fishing poles. Let P represent the number of poles they're buying. So if each pole costs $30, right, that means 2 poles is 60 and 3 poles is 90. So I'm going to take 30 and I'm going to add 30 over and over again based on the number of poles I buy. Well, what operation tells you to add over and over? That's multiplication. Even though you're adding 30 each time, this would be 30 times P, or 30P. If fishing poles cost D dollars, well, instead of costing $30, they cost D. Notice how this would be D times P, or DP. The only thing that makes the difference is that the dollars is D instead of 30. All right, let's go down now to the second standard. I can create and analyze mathematical relationships. Okay. Now, let's start with number 1. Amanda has $55 in her bank account. Each day for 5 days, she saves $5. Let X be the number of days and Y represent the amount of money saved. Now, Amanda started with $55. So that's not after 1 day does she have $55, but after 0 days. Remember, 0 is always the first where the starting point is. I'm going to go up by tens. I decided this because I want my graph to be on there, and I know we're going up by 5, so I can always go halfway in between. So we start at $55, and then we're going up by $5 each week. So every week I'm going up half a bar because the whole bar is 10. Tells me to label my axes as well. So this is days, and this is money. Now I should stop at 5 days because the problem tells me that I'm supposed to stop at 5 days. So you could space your days out a little more than I did, but I chose to go this route. And so I take my money. My money is always going to be my starting money, which is 55. And then plus my change times the number of days. So $55 plus $5 a day times the number of days X. And that is how you write an equation. I'm going to be really silly with this one because I like silly stories. So days, and we're going to go with Yoshi's. Yoshi's Island has 40 Yoshis. Every day, 5 more return home. Now you might be wondering, how did I know it was 5 more? Well, I know after 0 days we start with 40. And after 2 days we have 50. So that's 10 Yoshis every 2 days, which is once again 5 per day, just like the one we just did up here. So my equation would be y equals my starting Yoshi value 40 plus 5x. This is also true when it comes to these problems. So we have a case 0 here. I always draw case 0 first. And notice that every single round, they're just getting another block in the middle. So I drew my case 0 with 0 blocks in the middle. And so I'm gonna at case 100, I mean, case 1 had 1 in the middle, 2 in the middle, 3 in the middle, right? But then we always started off with the 6, right? And so I would say there'd be 100 blocks in the middle plus 6 blocks on outsides. And so 100 plus 6 is 106 total blocks. The way to show this, and actually instead of x and y, I'm going to do case and blocks. Let's show this in a table on a graph, right? So case 0 had 6, 1 has 7, 2 has 8, 3 has 9. Assume 4 will have 10. And so we'll put the case number here and the blocks here. 1, 2, 3, 4, 5, 6. We started with 6. And 7, 8, 9, 10. And so 1, 0, 0, 3, 4, 5, 6, 7, 8, 9, 10. I always like to start my baseline with 0. That's why the line is dark. It represents the x-axis. And the x-axis should always represent 0 for y and vice versa. Write an algebraic equation. Okay, so y, my blocks, equals my starting value 6. And I'm gaining 1 block every time. Now, if it's 1 block, you don't need this one here. You could just say it's x plus 6. You could say 6 plus x here. But I like having the 1 there. It tells me how much I go up by. And so if I use my equation for my 18th case, I just do 6 plus 1 times 18, which is 24. So that's modeling all of the retakes, questions from Standard 2. Let's go to the problems from Standard 3. Okay. Oops, here we are, Standard 3. All right, write an equivalent expression. And so here, whenever a number is outside of the parentheses, we're told to multiply. So we multiply by everything on the inside. 12 times 3 is 36, so 36k. 12 times 4 is 48. And that's all you have to do. When there's a negative, make sure to multiply a negative times a negative to get a positive. So this is going to be negative 2n plus now 10. This looks more complicated in problems like the one below, but here again, we're just going to take this negative 3 and distribute it first. So I keep my 14x, that didn't change, minus 24, 3 times 8. Now negative 3 times negative 2 is plus 6x, and then plus 42. From here, I can highlight my like terms. Here are my x terms. And here are my regular numbers. I have negative 24 plus 42 for my regular numbers. And so, oopsies. And so that is going to be 18 positive. And then for my 14 plus 6x is 20x. And voila. That's it. That's simplifying. Now, the ones below, these are tricky. You really have to think critically about what's on both sides of the equation in these next ones. So take letter A. I have 2 x's here. Here's my equal sign, and 5 x's over here. So I need to add a certain number of 2 x's here to get the total I have over there. I need 3 more x's. There's more than one answer to this. Some people do it a little bit differently, but this is how I do it. Over on this other side, I notice that I have a 3 and a minus 5, right? A 3 and a minus 5. So 3 minus 5 is negative 2. So I'm just going to add negative 2 over to this other side so that we get 5x minus 2 on the left and 5x minus 2 on the right. Now, I've seen other people, a student from my class, brilliant mathematician, what they would have done is they would have, instead of adding, they would have added the 3 minus the 5. Notice that there was nothing on this side. Just put 2. And then they would have put a negative 3x here to even it out the other way. Notice how you could put the opposite numbers on both sides to get the 2 correct answers. So there's more than one way to do the problem. But I like to think about it the way it's done on the top. That's how I'm going to do this one. I have a negative 5x here and a 2x here. So that means I need to add 7x to negative 5x to get my 2x on the other side. Again, you're analyzing like what's going to make these two things equal. So it matters where the equal sign is. If there's 2x's over here, I need 2x's over here between the 2 blanks. Now same thing, I have negative 3 plus 5 here. Negative 3 plus 5 is 2. So I need to add 2 over here to make sure that it's equal. Now here's a little bit different. Letter C. We have a negative 12x here, and we have a blank space to multiply this parentheses by. Well, I know that to get negative 12 with 4, I'm going to multiply by negative 3. Okay. So now when I do that, I get negative 12x, but plus 15 when I distribute. So I need to have a 15 here. That one's done more with the distributive property. All right, last little bracket. X more than 5x minus 2. So here we're going back to our number sentences. And so x more is a sign to add. So this is going to be x plus 5x minus 2. Right, we're adding x more to the 5x minus 2. And again, we have to combine our like terms here. This is going to be 6x minus 2. Right, those two x terms are like, so we can add them. Notice how something similar happens in the second one. This says subtract, but subtract from. So this x is going to be at the end. So we have 7x minus 2 minus x. But again, these are like terms. So we can do 7x minus 1x, which once again gives us 6x minus 2. Difference, just like subtract, difference of 7x minus 2 and x. We've just done that. We took 7x minus 2. We subtract the x. We get 6x minus 2. I'm going to change my color red here for this last one because it's a little bit different. So I have 7x minus 2 again. But this time it's just decreased, subtracted by 1. So this is 7x minus 2 minus 1, which is 7x minus 3. Clearly this one right here is the one that is different. And the reason why it's different is it was decreased by 1, not decreased by x. So 7x minus 3 does not equal 6x minus 2. It was different because we subtracted 1 instead of x. Hopefully you found this video and problems helpful. Please do not hesitate to reach out with questions.